Welcome to ED34B, 2017 Total Solar Eclipse Science.
Troy, could you close the door, the back door? Thanks, sorry.
And Impact 2. I'm Lou Mayo from NASA Goddard Space Flight Center, co-chair with Alex Young, also from NASA Goddard. And we have 11 exciting talks today to talk about people's experiences with the eclipse. So let's get started. Our first speaker is Hugh Hudson. He's going to talk about the Eclipse mega movie. How did we do?
Right, I immediately noticed a problem with my first slide. The title, How Did We Do, is presumptuous because it should be, How Did They Do? I didn't do very much, actually, but we had 15,000 people participating and are still participating, and it's they who should get the credit for what eventually comes out. So my role here was to kibitz on the science side of it. And I think many of you heard Lora and Calvin speak this morning, so the outreach and technology parts of it have been discussed fairly well. But I'll repeat some of this stuff because maybe people weren't all here. So just as an introduction, to use up 30 seconds here, I think we go to these eclipses for one of three reasons, or for maybe all three. The first is, of course, and the most important one, is because it's a very beautiful thing that you have to see. And the second thing, of course, is that it's a tool. This group is very familiar with this for communicating science, education, ideas across a broad community, or many communities. And the third thing, of course, is science. And that's something that's always novel. Every eclipse has an opportunity for doing new things, and all the people who study the eclipses scientifically try their very best to open up new parameter space within which one can make discovery and learn things. So in a sense, it's always a fishing expedition because the theories of what propels the corona are not really very good, not very predictive, and so they, like in much of astronomy, we rely upon the observations to guide us to understanding. All right, so with that introduction, our main purpose was to get this archive in the public domain as a reference, and I think that's maybe the first time this will have been done. It is done. It's in the public domain, it's there, and we've already started our first Zooniverse citizen science access to it. Calvin showed this. This has these three links. There's the Zooniverse link. The three links are the software that was used by Google to prepare this initial version of the mega movie. That's the first one. The second one is the actual data set where there's an SQL platform that anybody can operate. And I should comment, as Calvin did, this map was made within the last 2 weeks, a Google map made by a volunteer who just learned the SQL business, got into this database already by himself with no coaching, and made this interactive map, which is already getting a lot of traffic among our volunteer group because they can see where they were to within a meter or two because of the GPS geolocation. So you're all encouraged to get into any of those three links if you wish to. I won't show the movie. Calvin showed that just to show you this nice graphic. I will show you the very first image, the very first 1/4 second image in our database. And I found this by setting the exposure time to be 1/4 second. Okay, so this is a 1/4 second image taken by Anne, a volunteer whose name is only known to me as a 64-bit random ASCII string. Maybe it was one of you, but probably not. So what you can see there is the corona, but also Regulus. And I don't think you can see the star itself. If anybody can, please, there it is, in that box. Okay, yeah, oops, that's a good point. There. And you can see it much more clearly at the pixel level by simply blowing it up. One problem with these images, of course, is they're all too big to look at, and so you really have to poke around and play with the color table and the expansion factor and all of that sort of thing to see interesting faint objects like Regulus, which of course at this level is saturating this exposure at 1/4 of a second. You can see Regulus in images down to 1,000th of a second easily enough, and in exposures this long, under good conditions, there may be 10 or 12 stars in the field. which is very good for astrometry. So that was the first image, and that's it on the left again. This is the Morgan-Druckmiller sharpening scheme, which Juan Carlos implemented. Has done it systematically now for thousands of these images, and it works beautifully. And you can see that it looks almost nothing like the original image, but latent, hidden within the signal-to-noise ratio, the very high signal-to-noise ratio of this image, you find all that stuff that you can sharpen up and produce in a reproducible way. These are 3 images spaced by 51 seconds each by this unknown volunteer. And I tried to make a smooth movie out of these 3 frames, and I failed, so I was really pleased to see that even Matt Penn's rather nice Citizen Kate movie has some jitter. The only movie I saw yesterday with no jitter was the one that came from the WB-57, the most weird observation ever. It was very nice. So anyway, so that's the nucleus of a movie, right? And you can see that because these features are so reproducible, any distortion that happens from a natural source in the corona, we will be able to pick up with fairly high precision. And there are many possible sources of distortion that have been discussed yesterday, and but many more that you could just throw in there. Like for instance, the torque. What is the torque that is slowing down the sun that couples angular momentum out into the heliosphere? How does that actually deflect these streamers? Who knows? If you don't look for that sort of thing, you won't see it. I'm not saying we'll see it. Okay, so that pretty much is the end of the science story for Megamovie, because you will understand that these data are very complicated. There's 50,000 images taken with 700 or 1,500 cameras, and under adverse conditions in the sense of flat fields and dark scientific kinds of image preparation. The volunteers did the best they could, but it's going to take a long time to sift through and sort out what's happening. And so we intend to approach this. We have a very small team, basically me and Juan and Lora, I think, are the key people, plus the friends in Berkeley. But what we'll do is, of course, get people to help. And so we will try to get as much as we can get done through Zooniverse and public science things that we can arrange like that. The targets are, of course, precise structural changes in the corona, but also structural changes in the chromosphere and the photosphere. So this is a small branch part of this Megamovie was the app that we developed, a free app, which we tried to get into 1 million smartphones, but alas, only into a couple thousand. And you can see here Mark Bender in Patagonia testing the app in February. And here's a lens attached to a smartphone. You can do that, and you can get quite a good quality representation of the corona by doing that. If you have no lens, and here's my observatory in Corvallis, you can see by an amazing coincidence, all 10 of those smartphones are by one manufacturer and not the other, but they all worked. So it was wonderful to hear the sound effects as the second contact came and they started to click, 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 because the app actually guided the exposure sequence, and of course, while taking the pictures, it recorded geolocation and precise timing, which is essential because if you want to study the structure of the sun, you want to use this is the old Watts data, you want to use this detailed rock-solid astrometric reference of the shape of the moon to guide you to what's happening in the sun, right? And the sun here, this is a sequence of images that shows how libration affects the position of Bailey's beads as the eclipse sequence proceeds. That's from an airplane across the North Atlantic at some unknown eclipse earlier. So that's pretty much the story. The conclusions are that yes, the Megamovie business worked, thanks to all of these people. We have our public domain record. Science is in progress, so it's an ongoing thing. It's not a finished project at all. And like other people who've spoken to this audience, we would like to do this again in 2024, if not in 2019 and 2020 and 2023. Thank you.
Very nice. We have about a minute for questions and answers, hopefully, and answers. Yes, Shadia.
It's a beauty is in the eye of the beholder. I just learned.
Here.
I just learned this from Dave Conrading, who was one of the Google people. In my software, IDL, Y goes up, and in his software, Unix, Y goes down. So to a scientist, this doesn't matter at all. So you're a scientist, so you shouldn't care.
Jack?
Just repeat that for your data, so we have that software in place and ready to go.
Yeah, thank you for mentioning that. Jack has mentioned that there is a full-fledged Python analysis package. Now it's ready to go, and I would have tested it if I knew how to do that. But Juan has worked with it, and it's in pretty good shape. And so that also will be public access and useful, I think, for many people who want to work with these data.
Thank you. Let's thank our speaker again. Our next speaker is Jay Pasachoff, outreach to scientists and to the public about the scientific value of solar eclipses. And I neglected to mention at the beginning, these are 10-minute speeches with 2-minute Q&A. So I'll let you use 1 minute of your Q&A, and then I'll stand up, and then you don't want me to do that. So it's all yours, Jay.
Okay. Thank you, Lou. Thank you, Alex. Thank you, Hugh. It's a pleasure to get a chance to talk about some of the outreach that my group has been doing, that I've been doing, that the IAU Working Group on Eclipses has been doing, and we were able to observe the eclipse very well from Salem, Oregon. So there's one of our composite images. In particular, we wanted to talk about the international groups of people who we've sponsored through the National Geographic Society, through the National Science Foundation, through some NASA support for our outreach efforts here. And we have been doing this high contrast combinations of data that are showing the details. We've been able to see some motions already. Some of you saw the science paper on Monday. We did have a scientific team from various countries that are shown in red there. And I'm just going to go through fairly soon to give you an idea of the variety of things. This is a student group from Williams College, also with some of our alumni, so we're able to take quite a number of students to the eclipse and give them some scientific training to do that. And then in addition to our group from Williams College, again seen at the upper right, we had 50 Japanese astronomers who were with us and 28 Chinese astronomers who were nearby, who we helped and things, and some people from other countries who were with us in Salem and elsewhere. I just like this particular cartoon, how cool to see it in person on the left, and you can see that the actual solar eclipse is the top right, just off the charts, that it's so much cooler in person than it is the anticipation. So here I just want to briefly run through things from Nature Astronomy and Nature articles and the American Journal of Physics and the education blog of the National Geographic Society. So let me just run through some examples for you, and at the bottom we've thanked the various institutions that supported our work. My wife and I did a children's magazine called Dig Into History, a special issue in January that came out very nicely, I think, to show quite a number of people in their early teens, what things were like. I had a Washington Post op-ed to bring the eclipse coming before the general public and try to get them out. As you know, we tried to get 200 or 300 million Americans into the path of totality, which we didn't quite succeed in doing, but it would have been a good idea for all of them. There's a radio program on public radio and a podcast, academicminute.org, and I did one of those for the day of the eclipse, for the people who could still be gotten out to see the eclipse. 365 Days of Astronomy. It's been in CosmoQuest. It has actually since been taken over by the Astronomical Society of the Pacific, and we had a posting for that the day before the eclipse. I was glad to have a Scientific American article about the great solar eclipse of 2017 with some higher level diagrams and a way of showing eclipses over hundreds of years, and of course the text that went through that, including the overall orientation of the solar corona, and then a lot about the heating of the corona and the different models that there are for coronal heating, and had this diagram drawn for example, talks about the synoptic observations of the sun. Months before, we were reviewing various books about the eclipse. There were several good ones that came out. This particular review appeared in Nature, and with a good book by David Barron and another good book by Tony Avini with more archaeoastronomy in it. Frank Close, a particle physicist, about what it's like to see the eclipse. John Dvorak, a good general book about eclipses. And so we're able to present that to a number of people. Earlier in the Phi Beta Kappa newsletter, I had a review of the book by Tyler Nordgren. That was quite an excellent book that was out first of this group that I hope all of you have read. It turns out the August 21st eclipse was the same August 21st as the 1914 eclipse that Finley Freundlich went to see in Crimea just when World War I broke out, and some of you know the story that if he had observed that, Einstein would have been proven wrong. But fortunately, he was interned. And anyway, so my wife and I wrote an article about the August 21st eclipses, and incidentally, the amateur astronomer Don Bruns has now repeated the experiment at this last eclipse, getting a very good result, which we're trying to arrange for him to talk about at the AAS meetings. The National Geographic Education blog talked about outreach to schools, and there I am lecturing at the bottom right at a school, and there with the celestial buddies, the stuffed planets, to make the eclipse there, so that reached a school education audience. And then more technically, I had a resource letter on observing solar eclipses in the American Journal of Physics, with hundreds, over 100, about 150 different references in different categories. Andy Fracknoy came in with me on that. And so that was a good reference for the teachers of physics, especially who see the American Journal of Physics. On the overlap of art and astronomy, we ran an exhibition of art and artifacts related to eclipses at Art Center College of Design in Pasadena, California, all summer, including a display of 3 of Howard Russell Butler's oil paintings from the eclipses of 1918, 23, and 25, that being the best way to show the extent of the corona to overcome the dynamic range problem at least a bit. And so we were able, he did several sets, and we were able to have one of the smaller sets on actual display there. And then from the scientific point of view, for a more scientific audience, I had an article in Heliophysics, in Nature Astronomy on heliophysics and total solar eclipses, which summarized in quite a number of articles the various scientific papers about eclipses, since I had an earlier article in Nature in 2009 for the International Year of Astronomy. And of course, there are just some of the references we're running by there, but quite a number of references. And then we had a NOVA crew with us, so there was an hour-long program that played the night after the eclipse. And Mark Bender, whose picture you saw, had something in CuriosityStream. And then we had, and now there's a Japanese camera crew from NKTV who were actually with me here at this meeting and had been in Williamstown with me. They're making a 1-hour follow-up show about the eclipse from some months later. But the NOVA is available to see an hour long.
Right on the second horizon, we're getting in the umbra now. Disappearing. 15 seconds.
15 seconds.
You can certainly see the shadow coming.
Oh, it's really moving.
It would be better if the lights were off.
5 seconds.
was certainly dramatic from our site in Salem. I'm just out of my time during the question period. But you can see, as this persists, that 2 minutes is a very long time during an eclipse. You can take thousands of photographs at my site, not to mention all the sites that the mega movie had. Shadia Habal, who was here, and I were on the original white paper that led to the mega movie, and we're very pleased that the mega movie has done as well as it has. Thank you very much.
Do we have any questions for Jay?
We have a minute for questions.
Rick Feinberg has a
Yeah,
question
Rick.
here.
I just want to make a comment. I don't know, I always marvel at how long an eclipse seems to last when you watch it on video later, relative to how long it felt when you were there, and it seemed like it was over before it began.
Einstein had a quote about relativity that was related to that. Yes. And
Talking about time dilation, this is the opposite.
no other question?
Other questions? Okay, let's thank our speaker again. Our next speaker is Stonie Cooper. His talk is entitled Use of the Nebraska Mesonet to Engage the Public in the 2017 Eclipse Event. This is the laser pointer.
Laser pointer and mouse for you. Whoops. And I just have to,
Oh, you're working.
Yeah, we got this. I'm Stonie Cooper with the Nebraska State Climate Office. Just to start off with the definition, because I do get a lot of what is a mesonet as opposed to a mesonet. A mesonet is a collection of weather stations or a weather network, and in the case, I'm the manager for the Nebraska Mesonet, which is 64 weather stations in Nebraska. Who we are, the Nebraska State Climate Office is a very small office. We have 2 faculty, 2 staff, of which I'm one of them, and then 1 part-time staff. The 2 staff members make up the entire Nebraska Mesonet staffing. I'm the manager, and the other person is a field technician. We manage 64 monitoring stations, which is just a glorified way of saying weather station. We also run our own calibrations lab, so we do almost all of our own calibrations on the instruments that we deploy out in the field. The authors that contributed to this presentation, myself, Glenn Robke, who's my technician, and I want to point out that a lot of research and a lot of ideas come from the bottom up. It was his idea that I present here at AGU. I really do think that really what he wanted was a week off because I'm here. Shauna is our communications director. She did a lot of tweeting in reference to our website that we're going to talk about in a little bit. And then Dr. Martha Shulsky is my boss, and she also did a fair amount of tweeting as it applied to a quick and temporary website that we put up to try to do outreach to extend our audience of the products that we provide as a Nebraska State Climate Office to a larger audience that includes astrophysics or astronomers. The opportunity that lay before us is the fact that we had the path of the total eclipse at the surface, and I want to point that out at the surface for William here because he's going to talk about the ionosphere. And the last time Lincoln in particular that had anything close to a total eclipse was 1442. So this is not only a once in a lifetime event, but this is a once in a several generation event. And there is a picture of one of our weather stations, just to kind of give you a few. On those individual weather stations, we have pyranometers, temperature sensors, barometers, and as well as precipitation gauges and a lot of soil instrumentation. But we're really going to focus on the things that are above ground. The observational potential here is we record data every 5 minutes average, as well as min and max for the different parameters within that 5-minute span. One of the things that kind of came together with this particular event is a launch of a new GOES-R satellite, GOES-16. And that provided us with some fresh instrumentation, a lot more spectrums than had been available in previous GOES satellites. The other thing is we also researched new instrument paradigms for weather stations, and one of our current research projects is upward-looking fisheye cameras for sky conditions and doing automatic analysis of cloud cover and such from those cameras. And in the next slide, one thing I want to point out, because what is the most evil thing that can happen during an eclipse? Clouds. So in the next slide, I'm going to show you a GOES 16 loop. And as you watched in southeast Nebraska, close to where Lincoln is, we had clouds. And that's going to show up real prevalent a little bit later. There was a lot of people who paid thousands of dollars to come and see this eclipse in Nebraska, and they got to see cirrus. The camera, and notice the bottom here is actually a loop. So we're actually watching a time lapse from our fisheye camera. In this case, it's been drawn out into a panorama. So you get a view of what the clouds look like, but we were still able to see the eclipse. The upper left-hand image is from the competing cell phone manufacturer. Shout out to our Google friends. And that's just a naked lens. There was no special filter or anything applied. That was at totality through the clouds. Oh, look at that. There goes a shadow. I think that's a cool image. There's a science behind the eclipse that we wanted to reach out to our stakeholders in the state of Nebraska and show to them that what is the totality of the effect of radiation when it comes to the surface. And obviously, one of the first questions you get is temperature. What is the effect? And in these graphs, you have 3 different locations that I'm just providing a sample for. And the black line is the reading from the pyranometer. And our pyranometers measure the downward shortwave radiation between 400 nanometers and 700 nanometers. And in this case, this is our temperature profile at the same time. As you can see in the far western part where there was no clouds, we had a great response of the temperature in relation to the radiation that came in. And if you haven't already figured out, the great big valley is the eclipse. This is an eclipse seminar. But as you had clouds, especially in the eastern part of the state, that effect was more muted. Wind speed, and this is one thing that a lot of people don't get. And I'm a meteorologist, so I'm a little bit of a fish out of water when it comes to astrophysics, which I'm assuming a lot of you are. And by the way, my son is studying to be an astrophysicist, and I said, what would be a big hit when I come into a room full as a meteorologist? And he said, just mention 2 words. Big Bang Theory. And then I pointed out to him that English is probably not his strong point. With wind speed, we can see that there's also an inflection based upon downward solar radiation. Whereas out in the western part of the state where there are no clouds, you can actually see that decrease in the wind speed in the center part of the state where you had a few clouds, but not as much as in eastern. And then when you get in eastern Nebraska, there was hardly any signature. Whoops. Too far. And then finally pressure, because you not only want to get the feel for the affirmative in a response to something, but what doesn't have a response to, and pressure is a good example. There is no correlation whatsoever between the pressure and the pressure change as it compares to the pyranometer readings. So we have the science, we have this great event, we have this opportunity, we have a network of observations. So how are we going to use it to reach out to our stakeholders? And actually we're using this as an advertising bit to try to draw them in. You make a web page. And so we went out and we created eclipse.unl.edu. By the way, University of Nebraska, Lincoln, so there's no confusion as to what UNL means. And I had 2 weeks to do it. And going back to that second slide, there's 4 of us, and I get to do IT work as well as manage the network. So using Drupal 8, quickly made a web page, put some products on there. In this case, we put the camera, and we put the GOES 16, and we put some of the 5-minute data up. How do you get people to come in? What we utilized was Twitter. The director of the State Climate Office, as well as a communications officer for the School of Natural Resources, which is where we're embedded, they then started to tweet about this website's presence. And so this here is kind of showing the value of social media. The red lines, the big red lines, are what are called impressions from tweets. And those are parameters that you can get back from Twitter when you tweet something. And by the way, I don't tweet and I'm not on Twitter, so if I'm speaking incorrectly about some of this stuff, you can correct me after my presentation. The gray lines are the actual hits to the website, and the little green lines are the tweets that came out of the School of Natural Resources. There was only an initial response to tweets that were reflected in an increase in traffic. And our friend from Google is going to like what I'm going to say, because in looking at the data later, what really drove people, especially on the day of, where you see the peak of traffic, what really drove traffic to it was the Google search, Nebraska Eclipse. So in conclusion, if you just create a web presence, it's not necessarily sufficient to bring visitors. If you build it, they may not necessarily come. So if you just make a web page, that is not necessarily enough. You have to do the Google Analytics, you have to tweet it, you have to put it on social media. Although social media may drive some visit, it doesn't necessarily create a sustained interest. So we had those tweets out early, a week before the eclipse. Once those people came and looked at what the website was, they moved on. In the impression penetration, and impressions going back to, that's a Twitter metrics that you get back that says how many visits you got, is not a predictor of hit concentration. And then ultimately, the content must be relevant and interesting for people to stay and come back to your website. And that is all I have.
Okay, we've got about 30 seconds, time for maybe one question. Okay, let's thank our speaker again. Okay, our next speaker is Rob Semper, Navigating the Path of Totality, Results and Lessons Learned from the 2017 Eclipse, Broadcast, Webcast, Mobile App, and Online Production. It's all yours.
Great, thanks Lou. It's my pleasure to be here to talk today a little bit about the work we did to do live streaming about the solar eclipse, a little about the results of that, and some very interesting results about Twitter analysis of what happened during and after the eclipse. We've been covering eclipses and broadcasting them since 1998. Lots of times it's kind of an interesting but lonely process because it's coming from all over the world. It's a wonderful experience, but here in the US, of course, there isn't the excitement that this last eclipse brought us. So this one is quite different, and for us it was a way to think about how to do a broadcast that was actually contributing material for all of the other projects that you've been hearing about today and all the other projects that NASA's been doing. So for this eclipse, we decided to do it from two different locations, from Madras, Oregon, and from Casper, Wyoming. The idea was to actually, first of all, tell a story about the travel of the eclipse from one place to another, which we hadn't been able to do when we were doing just one-site broadcasts. But also, of course, we actually found these places that had really good weather. They were early in the path, so we could tell the story at the very beginning, and we had sort of backup between two locations in case we got clouded out. At each location, we had 4 telescopes, two that were doing whole disk and 2 that were doing quarter disks, and they had white light and H-alpha filters. And we actually produced 3 3-hour broadcasts and 2 one-hour broadcasts, one in English and one in Spanish, using a full HD studio broadcast system. The broadcast streams were done in this way, and at the bottom of the screen you can see actually, let's see, there's a pointer here somewhere. At the bottom of the screen you can see the times. This isn't a mistake in my layout. It actually shows that the first batch of streams coming from Madras, of course, started 22 minutes earlier than the ones coming from Casper. So this was a sort of telescope-only feed from beginning to end, one from Madras, and then one from Casper, and then one also from Casper that had sonification, sound that was actually created primarily by the light that was coming from the sun, and also a piece done by the Kronos Quartet during totality. We also did 2 one-hour programs. They, of course, started around totality in both locations, one in English and one in Spanish. These programs were then distributed through satellite, which provided video feeds. Satellite also went to fiber, which provided fiber video feeds, which then went to encoders to provide internet. And the reason it was done this way was to provide the material to all of these different platforms, these different people who made use of these different kinds of feeds. This live telescope feed of the telescope only turned out to be a primary use for many of these sites because the imagery was then embedded in the programs that other people were doing. So it wasn't just things that were produced on our website or NASA website. It was used by many, many, many of these different providers. On the next slide, I can show images, the NASA TV and web, which we talked about earlier today, but also broadcast television, in school activities, in libraries, social media live, apps are produced both for Apple and Android, websites that were other folks' websites that use the feeds, museums that are all over the country, and very particularly a Spanish language feed that actually reached about 1.7 million speakers of Spanish. A really great new opportunity for us to do the first one we did in Spanish. Here's the distribution and the kind of results. There are 5 live streams. There are about 14 different platforms that I've talked about, reaching approximately 63 million viewers. And the stats are here. I won't go over all of them. Some of them are pretty interesting that we haven't talked about earlier. For example, this broadcast TV stat, they estimate 25 million people saw it on broadcast television. So we think of television as being an old hat, but it actually turns out to be still a primary medium for many people watching. Some of the other stats are here, including the visitors that were at the library programs you'll hear about later, visitors to the museums that are all over the country, and students and teachers in unknown schools, which is hard to get some data about. So this is the results of the project, but I want to talk a little bit about the social media experiment, which is pretty interesting and at least to me, quite new. There's a project by our evaluators called Social Media Listening. The EDU actually did a deep analysis of Twitter data. They looked at 16.5 million tweets on the topic of Eclipse, Science, NASA, and Exploratorium. And those tweets they analyzed for elements of sentiment and also the use of rich STEM words. And if you want to see the report in detail, it's been posted on informalscience.org. But let's look at the data. Now, this data is a little bit hard to understand, so if you look up here in the corner, here's the key. This is a sentiment analysis. In other words, it's a word analysis of tweets to find out what people are saying. They're saying great, wonderful, fantastic. Those are kinds of indicators for sentiment. There's most positive and positive. And you can see it goes from these different colors up to blue. This is the day of the eclipse, 1.4 million tweets here. You can see the amazing thing is that day very strong, but the next day pretty strong, and the next day pretty strong. And then if you look out here, look at how the sentiment even improves in terms of people's feeling about being in the eclipse. It just shows how long-lasting this experience was for people. So this is kind of like, wow, what a great experience. But let's look a little deeper at the science that's underneath it. This is a STEM word cloud that was created by analyzing those tweets. So the bigger the word, obviously, the more often it was used. This is purely based on numbers. 16 million tweets were analyzed. But you can see the words in here. Not only have solar, eclipse, things you would normally see, star, but you start to see corona. You start to see even much more detailed things like constellation or hydrogen, or there's some other words in here that you really would rare, exoplanets, things that you wouldn't necessarily find in the general public. This really showed the power of the whole eclipse experience. It wasn't just the video this is about. This is really about the entire eclipse experience, because the tweets, of course, are about everything people are seeing. And then you can do an analysis by time on these words. And here again, the key is over here on the right. Blue is the most STEM words. Brown is sort of least STEM words. Here you have a buildup before the eclipse, more and more interest. During the eclipse, it's sort of a lot about, hey, where is it? What am I doing? But now look at the day later. Many, many more STEM words talked about. 2 days later, many more STEM words. Even out here, 3, 4, 5 days. Again, a very unusual impact. And you can go deeper. This is how many STEM words, a few or many, from kind of a peach color to blue. Here's the day of the eclipse. Look at the next day. All of a sudden, you get a lot more rich discussion, and even the next day, a rich discussion. So this kind of after effect was very strong with this experience, something much more significant than one might expect for sort of one-hit wonders that you might think, well, it went out of people's minds. And even to confuse you more, here's a data chart that shows it by hour. So here's August 20th, August 21st. The eclipse happened on this time right here. Again, peach is sort of like 1 comment, green 3 comments, blue even more. A couple interesting things. One, you see this peak happened before the eclipse. And of course, this is based on all the news that was happening the night before. People were really excited about the eclipse coming. And you also have to realize this data is, while the time down here, specific time, Twitter data is actually driven by users, and users are mostly on the East Coast and the mid part of the country. So the data is always time shifted by the fact that the majority of users, just by numbers of population, are on the East as opposed to the West. Here's where eclipse started. You can see again this effect the next day and the next day of interest in talking about the science behind the eclipse. I think these are really heartening results. And so finally, lessons learned. Participating in a live science event can produce extended public engagement in science. Live streams can serve an important foundational component for on-path and off-path audiences, particularly ones that were in clouds, but they're on the path. They got to see some of the media video. It helped enlarge the experience for them. Spanish language content can reach a significant audience. I think it's an underrepresented component of the work we do in science education in the country. And finally, the collaboration between NASA and public science education community can produce a high access and high impact event, which I think the eclipse certainly proved to be. So thanks very much for your time.
We have about a minute for questions. Paul.
Well, what do you, I think all of us will be interested to figure out what is the, what's the momentum and what are we going to do to take advantage of an event like this. And I think it is really, really unique, but I think it's lost if we don't take advantage of it. So it'd be interesting.
Right. Well, 2 thoughts. One is, Robin, my colleague, pointed out that the night after show was that PBS did was an incredible opportunity. If you see this, if we had done stuff the next day, we actually missed it. Of course, we're all exhausted. We all go home. We basically party. It's wonderful. That next day was a powerful time that we actually missed. We could have done a lot more in that time, right? We could have extended what happened. So I think that's a great lesson for next time. The other is this eclipse had so much great preparation. I think as we go forward, we have to figure out when they're not in the U.S. with all of that news boost. I mean, we got a tremendous boost from broadcast media, all these other folks. We didn't do the marketing ourselves, quite frankly. It was all of out there that brought the numbers in. We're not going to have that for the next few. So how we actually generate value to that is going to be a longer, more precise haul, I think, to get that to happen. Great.
Thanks very much, Rob.
I know I have to switch the screen. So.
Might have to give AGU some feedback on their switching back and forth. Our next speaker is Amy Keesee, who will be talking about bringing the Great American Solar Eclipse to West Virginia.
All right, thank you. Okay. All right, so I'm going to be talking about the outreach work that we did in order to reach people in the state of West Virginia. Of course, I want to acknowledge my collaborators, Catherine Williamson and Jennifer Robertson-Honecker, as well as all the support that we got locally from our university and from the Space Grant Consortium. All right, so we wanted to take advantage of the eclipse in order to reach a population that really is underserved in terms of STEM. West Virginia is the only state that is completely in the Appalachian region, so it's very rural, and they're not exposed to very many opportunities in STEM careers and understanding what sorts of STEM work is going on in the country. West Virginia ranks the lowest out of all 50 states in the percentage of people with a bachelor's degree at 17%. And if you get into some of the more rural counties, especially where a lot of the coal mines are, it gets really low. And so people aren't exposed to people that have bachelor's degrees and the type of careers that they follow, especially in the STEM fields. So there's a lot of studies that look at how to expose students in rural Appalachia to STEM experiences. And it's really important to engage them with their community. Family and community is highly valued in the Appalachian region. And so it's important that when you do STEM opportunities that you include the community and family, and that will have the greatest impact. So we wanted to take a multi-pronged approach in order to make the biggest impact on as many people in the state of West Virginia as we possibly could. And the best way to do that was to utilize networks that are already in place. So we wanted to start out with engaging the formal and informal educators and take advantage of them to really spread the news of the eclipse and get the students and the communities excited about the eclipse itself. And so we were able to get funding to buy a bunch of solar eclipse glasses, and we distributed it via those educators. We also worked with the statewide 4-H program. So that is a youth program that is run by the university's extension office and is in all the counties throughout the state, so that you can really get the youth that are involved in that program during the summer leading up to the eclipse. Now, when we were thinking about what we wanted to do locally at the university, we realized that most of us wanted to travel to totality. So in West Virginia, it was just a partial eclipse. It was sort of an 80 to 90% coverage. And so a lot of us working on this realized we wanted to go to the path of totality and weren't going to be there the day of the eclipse itself to host a viewing. And so we hosted a pre-eclipse event at the university on the Saturday before the eclipse. And that invited the public that was in the region to take advantage and learn about it. And I'll be talking about what we did in a little bit there. And then we got student volunteers that were not traveling for totality to host a public viewing the day of. And that was primarily the university community. So a lot of the students and faculty and staff got to take part in that. And why this is really important for us is because West Virginia University is the flagship university in the state. It's also a land-grant institution. So it really is our mission to work, especially with the extension program that works on the 4-H program, to really share what's going on at the university and engage and inform the public throughout the state. Okay, so this talks about the distribution of eclipse glasses. This was sort of one of our big ways to reach the most people. So we were able to get 31,000 glasses through our different sources of funding. And then we distributed them, like I said, mostly through the educators as well as through the 4-H program. And we found the demand was much greater than the supply that we had. So we contacted our science teachers list, and we also have an educator resource center at our NASA facility in Fairmont, West Virginia. And so we utilized their listservs to get the word out that we were going to be distributing solar eclipse glasses. And the demand for them was amazing. So teachers would tell us how many they would like to get, and told us a little bit about what their group was or what school they were from. And so at some point, we actually had to cut off the request list because we were getting way more than we would have ever been able to distribute. Closer to the time, we were able to get a little bit more funding, ordered a few more, opened it back up, and again, got just inundated with requests. So what we ended up doing was to send lower numbers than what was requested. A lot of the schools requested one pair of glasses per student. And so what we did is we sent less than was requested the students, and then encouraged them to share the glasses among the students, telling them, you don't need to have the glasses on the whole time. They can be shared so you can experience, especially since we didn't have totality, we could take advantage of the full time. We also talked about using projection methods in order to still be able to experience the eclipse if you're not wearing the glasses at the moment. We did prioritize 6th grade. So if there was a 6th grade or a middle school that had requested it, we tried to get closer to fulfilling their full request because the eclipse learning was in their 6th grade science standards. So that's why we prioritized that. So this map shows where the glasses went. And we were actually able to distribute to 53 of the 55 counties that are in our state. But you can see from the dots that it really covers a good portion of the region. This is actually some of the national forest areas, so there's not much population there at all. The blue is in-school educators, and then the red is some of our after-school programs that were requesting glasses as well. So you can see we got a really good distribution around the state. So along with the distribution of the glasses, we wanted to make some professional development opportunities for the educators that were taking advantage of the glasses. And so we created a website where people could go, and we developed these videos that talked about what is an eclipse, how to view the eclipse safely. We picked out some activities that were relevant, a lot of size and scale type activities. Talking about the sun, and that included information about the research that faculty at West Virginia University are doing that's related to the sun, so they could really engage with the university and understand what's going on in their state in terms of research. And then we helped them develop eclipse action plans, so they could organize some event around the eclipse and really be prepared for it. And then if they completed all this and then followed up with us after the eclipse, we gave them a certificate for their professional development. We also created a Facebook group where people could share resources and answer questions, and so we monitored that and kept up with what things that were going on and some interesting things. Like when people posted pictures of using the paper plates for the younger kids to block out the sun, we shared that on the Facebook group so people could see some other ideas. We also hosted 3 video question and answer sessions for the educators. That was hosted by myself and one of my colleagues, so that after they had watched the videos, if they had further questions about implementation, they could talk with us about that. And like I mentioned, we used the West Virginia Science Teachers Association and the Educator Resource Center at NASA's listservs in order to do that initial communication. And this is a picture of one of the middle schools on the day of the eclipse using their eclipse glasses. All right, so like I mentioned, we hosted a pre-eclipse open house at the university on the Saturday before the eclipse to engage the public that was in the region. So we had several different activities that they could take part in. We had the faculty give a series of different mini lectures talking about some of the research that's going on, understanding what's going on with the eclipse, and talking about how to view it safely. And they did some demos as well, so they could understand some of the science behind the eclipse and solar research. They had access to glasses. The kids, we gave out the colorable ones, so they colored the glasses and tried them out. We also had a series of solar telescopes out front that they could look at using those, as well as sun spotters. We had our planetarium show that ran a series of, the planetarium ran a series of different shows that people could watch throughout the day, as well as our rooftop telescope we had set up for viewing. And then we had a number of other hands-on activities that they could take advantage of. So we had over 1,000 people come to this event. People were very excited about getting eclipse glasses from this event. So it was really popular. And we did do a survey of some of these people and got some good evaluation about the impact that was. And then finally we had our eclipse viewing the day of. We had a lot of student volunteers running some of the scopes, as well as an astronomy class that had glasses that they could share with people. This is the Mountaineer. He's our school mascot. And so that's them, and you can see sort of the crowd of people that were out in front of our student union checking out what was going on during the eclipse. So challenges and lessons learned. Our biggest challenge was that the eclipse occurred at the beginning of the school year, and so communication and planning with educators was really a challenge. We had the videos out, and we had the Q&A, and they were like, oh, we just haven't had time to think about it yet. And then trying to get the communication out to the parents was a challenge as well. It also occurred at the end of the day, so there's a lot of transitions going on at the time. Last minute fears that I know a lot of people had to deal with, we weren't really prepared for, so some of the events ended up being canceled. And so we need to engage all levels, including the administrators, so they know what's going on and we can deal with those challenges. So again, better communication at all levels, along with how to view it with a projection method to get rid of some of those fears for safety. And a big thing that we noticed is that the eclipse really sold itself. Like the person before me talked about the media talking about it. So the eclipse is really something that's different than a lot of other STEM outreach in that the public is hungry for the glasses. We just said, we're doing it, they came for it. We didn't have to say, why is it important for you to learn about this? They just wanted to be a part of it. And when we looked at how many glasses we distributed and some of the surveys of events that the different educators told us about their events, we estimate that we reached over 50,000 West Virginians with our work. Thank you.
I think we're out of time, so if you have questions, please see Amy after the session. Other switch. Thank you. Okay, our next speaker is Michael Kirk. We'll be talking about a unique eclipse outreach approach, sustained engagement in an underserved community. Michael?
All right. Thanks, Lou. My name is Michael Kirk. I'm really pleased to be here today. I am a research solar physicist at NASA Goddard Space Flight Center, and I'd like to tell you about a passion project of mine that has been brewing for about the last year and a half. I grew up in Oregon, and with the total solar eclipse going through Oregon, I thought this was a fantastic opportunity to do some public outreach. So as a little bit of background, the eclipse went directly through the state of Oregon, but specifically we were focused on Central Oregon and Madras and Warm Springs. I'll zoom in right there. Madras and Warm Springs is about an hour south of, two and a half hours south of Portland and an hour north of Bend, Oregon, in high desert community, so fairly dry and clear skies. About the communities, these are small communities. Madras has a population of about 7,000, Warm Springs is about 5,000. A quarter live below the poverty line, about 20% speak Spanish at home as a first language. 80% of these students qualify for free or reduced lunch programs, and 43% of students drop out before high school graduation. And yet this was one of the best places in the entire country to see the eclipse based on the access to highways and freeways as well as cloud cover. And so this really presented a great opportunity to engage the community in three different ways. One is to work with students in a K through 12 with the school district to teach them about the sun and STEM science in general. Engage the residences, the people that were going to be there, that were going to be hit by this tsunami of people coming through, to educate them about why people were coming, what was exciting about this eclipse, and what they could take out of it. And finally was to provide safety information to all of the visitors that were coming through. There are projections of hundreds of thousands of people coming through well before the eclipse day, so we knew that it was going to be big. So we did that through three different things: student engagement, community outreach, and visitor education. Starting off with student engagement, we worked closely with the Jefferson County School District to do a series of events to go in and talk with individual classrooms and individual students. And this actually happened over a series of visits. It really took a sustained interaction with the school district to organize some of these activities and to create this sort of curriculum. And so the initial planning started in 2016 over a couple of beers in Bend, Oregon, and then progressed all the way into March, where we did an initial outreach event. May 15 through 19 was our big event, and that's where we did most of all of our classroom visits. And then again, we followed up right before the eclipse to hit the summer school students. Summer school students are often the most at-risk students, so we wanted to make sure we targeted them specifically. And then we plan on going back again in the spring of next year to do some reinforcements. So the classroom visits, I personally, and Dean, my colleague, personally visited every single K through 12 classroom in the school district. So we spoke to more than 3,000 students directly, one-on-one. I think I said the same thing more than 22 times in a row one day. It was kind of crazy. But we really divided it up into two different types of activities. The K through 5 students were really hands-on activities. These were very hands-on engagement, like creating solar eclipse glasses, like coloring them, working with sundials, that kind of activity, hands-on activities. 6 through 12, we did much more of a STEM education approach, as in being a scientist isn't scary. It's actually a pretty good career. If you are interested in going to college, going into science or engineering is a great way to go to college. So we tailored our message to the age group of the kids. And then we also partnered with Lowell Observatory and the Oregon Museum of Science and Industry, OMSI, to run parallel events so that OMSI had a planetarium set up so that kids could go in and see the nighttime sky as well. So we reached over 3,000 students with student engagement, community outreach. We partnered with several different community organizations to extend the community outreach. We worked with Oregon State University, specifically their graphic design department, to help create up promotional materials, posters, and they actually designed a mission patch for us, which is what you see at the bottom there, which was really fantastic. We also worked with the Warm Springs Tribal Council to do reservation engagement. Working on a native reservation, it requires a lot of personal one-on-one interactions, and so creating those communities, that sort of outreach, one-on-one outreach with Tribal Council really allowed us to have access to the reservation itself. Worked with the Jefferson County Chamber of Commerce to do business engagement, and Georgia State University. We had a graduate student there do Spanish translation services for us, so we could actually have all of our materials translated into Spanish by a native speaker. But our two major partners were the Museum at Warm Springs and Madras Performing Arts Center. The Museum at Warm Springs hosted a couple of events themselves. They have you can see some photos of that, including translating, one of the coolest things I thought was translating total solar eclipse into a native Ichiscan, one of the tribal languages there. And then we integrated that into our graphic design, which was really great. I'm not going to try to pronounce that, but they distributed over 7,000 pairs of glasses. There happened to be a lot of wildfires during that time, so they distributed them to firefighters as well. And then the Madras Performing Arts Center really helped us engage with the Madras community itself. They distributed over 11,000 eclipse glasses to county residents to try to cover every single person in the county. They hosted two keynote events in May 18 and August 17 to engage the community. You can see a picture down there in the lower right-hand corner of one of those events where we taught the community members about solar physics and then taught them how to use eclipse glasses. And then the NASA HEC group provided a bunch of solar eclipse glasses. You can see the boxes stacked up there that we were able to use. Last but not least, we wanted to do visitor education for people coming into town. For that, we partnered with Oregon Solar Fest, which was a for-profit festival. So they brought in porta potties, they brought in camping equipment, they brought in food, and they gave us a building on the Jefferson County Fairgrounds to occupy. This reached over 9,000 people on one-to-one interactions. We had over an hour line to get in the door. And we had 11 subject matter experts answering questions and engaging with people, as well as 12 additional volunteers. So just the weekend before the eclipse, we had over 4,000 hours of volunteers contributed to this. We ran hands-on science activities, including the eclipse masks, doing science demonstrations. You can see we had telescopes set up. This was really to engage with people that were already enthusiastic about science. One of the most successful events, though, was building solar filters. We got bulk solar polymer film and then took cereal boxes, and you can see a picture of one of those and sandwiched a piece of solar polymer film between two cereal boxes so that people could hold it up to their camera to be able to take pictures safely. And that was extremely popular. I mean, more popular beyond our wildest dreams. People literally stood in line for hours to be able to make this thing. And we really had no clue that it would be that popular. But so if you'd like a hands-on event for a future activity, I highly recommend it. It was fantastic. Last but not least, we had science talks. So subject matter experts, including myself and Dean Pesnell, who's here, gave 15 short talks about science, about NASA's role in the eclipse, about understanding Earth science and the sun itself. And then we also gave additional 12 informal talks indoors in front of the TV screen, where we were able to engage with people a little bit more one-on-one to answer specific questions and address some of the specific concerns about eye safety or about eclipse safety that people might have had. And so having that two-pronged approach allowed for a little bit larger audiences at the outdoor event, and in the indoor event, we were able to do a little bit more of an intimate one-on-one interaction. So with the visitor education, again, we reached over 9,000 people. These are face-to-face interactions. This is me talking to you sort of interactions. So we're quite pleased with that. But in all, it was really partnerships that made this successful. I mean, I cannot stress this the most. I mean, the biggest lesson learned is that this was really a collaborative effort. I mean, we had over 44 scientists, teachers, educators, museum staff, students, and volunteers representing 16 different organizations and programs, donating their time to make this happen. And so it was really through this community effort that we were able to pull this off. Thank you very much, and I'd be happy to answer any questions.
Okay, we do have time for some questions.
So, would you do it again in 7 years?
Maybe in 7 years I will have forgotten how exhausted I was, and maybe you could convince me, especially if it was in Mexico, like on the beach in Mazatlan or something like that.
Other questions? Okay, let's thank our speakers one more time.
Swap these out. Can you grab those? There you go.
Here's your laser.
Switch the screen. Just
Yeah, machines that do that. Okay, so how do I advance?
Okay, just use the arrows if you want.
Hey, let's see. Okay, our speaker, next speaker is Bill Liles, Eclipse Mob. Should be interesting. Results from a nationwide citizen science experiment on the effects of the 2017 solar eclipse on low-frequency radio propagation.
So thank you, and greetings, everybody. So the folks that are on the photo is basically the leadership team and the outreach team, and those little symbols on the map is where we had receivers that we crowdsourced across the United States. But we also had them in Honduras and Canada and a bunch of other places. So, as you've already heard, the eclipse sold itself. Totally true. But selling the eclipse for people to do a crowdsourced effort when they've never even heard of low frequency, let alone heard of the ionosphere, took a little bit of work. So we had to start out saying, why is it important? Because people want to do crowdsourced stuff, but they want to do something that they think is relevant. So we had to explain to them, well, you've heard about GPS? Signals go through the ionosphere. It's important to know about the ionosphere. And as you probably know, there was GPS errors during the eclipse because of how it affected the ionosphere. So we had the primary research questions that we were going to answer. We had to explain to them what ionization was. They didn't know, right? So we also had to explain what the ionosphere was. So as you folks probably know, during the daytime, the D layer is heavily ionized, and it's very absorptive of RF beneath a few megahertz. So lower frequency signals don't get through, don't get refracted back down to Earth. At nighttime, there's recombination, those signals go. That ended up being one of our first errors, because the standard example is, okay folks, have you ever heard an AM radio station at night that's far away and you don't hear it during the day? K through 12 folks have no idea what AM radio is. So that example, and the reason I got interested in radio as a kid, doesn't work anymore. One high school kid actually says, I think my parents' car may have a radio in it. But that was as close as we got. So we had to end up, explaining a lot of just basic sort of things so they would understand. But they did get excited and did get energized about it, which is great. So what we're listening to is a radio station called WWVB in Fort Collins, Colorado. That's the station that the US government runs that sends out the time signals for your watches and clocks and everything. Because most eclipse studies on radio wave propagation is a separate receiver transmit pair, somebody else listens to another transmitter, somebody else listens to another transmitter. People don't listen to the same transmitter, so you can't compare any of the data. So we said, okay, we're going to pick one transmitter that has coverage across the entire United States, and we want people to listen to it who is on the same side of the eclipse path of visual totality and on the opposite side. Now, when we started making kits available, we just shipped them out to whoever requested. Guess who requested first? This coast. So guess how many I had out on this coast? Not so good, but we did get some out, and we got some spatial distribution, which is what we were trying for. So the actual antenna of the transmitter is a wire. You probably can't see in this picture. It's a wire right there. Those towers are not the antenna. They hold what's known as a capacitive top hat of the antenna, because it's pretty hard to make an antenna at a wavelength for 60 kilohertz. It's 5,000 meters, you know, kind of hard to build one that way. But we have all sorts of people building it. Simple little kit, no soldering required. We didn't want to have these folks have to have any mechanical, electrical skills to begin with. And we even included the kit a stripper, so people could strip the wires. Okay. See this plot? That's what was looked at 75 kilohertz with 5 different receivers looking at a 1999 Eclipse. Okay? It doesn't look like anything smooth. That's what we were trying to figure out how to handle. So, we had to design it, create portals, yes, websites, Twitter, Facebook, all that stuff had to be done. We had lessons plans. We had included in those lessons plans, like, if the sun goes east to west, why is the eclipse going west to east? Because folks didn't perceive that naturally, okay? Got in with libraries, museums throughout. Like I said, we had youth building these things. 150 kits delivered. A bunch of people, when we ran out of kits, they just ordered the parts online themselves and built their own. It was great, okay? Okay. We started out by having senior design teams at the different universities do this stuff. I probably won't ever do that again. Once they knew they were going to pass that course, they lost all interest. So they would write the app for, let's say, an Android phone, and then guess what? They didn't finish the app because they knew they were going to graduate. Not good. I need finished apps. So probably do this a little bit differently next time. But they learned a lot by doing it. Don't get me wrong. The students learned a lot. I just didn't end up with the products I needed. Okay. We started advertising this before we had the apps finished, before we had the kits ready to go. We won't do that for the one coming up in 7 years. We'll have it all laid out beforehand. And we would test it. The app for the smartphones changed the day before the eclipse. You never do that. And we think some bugs were introduced, so now we have problems getting some data. We ran webinars for this that met the next generation science standards, so the teachers got credit for it, which was good. So we had people from all over the United States going into the webinars. As I mentioned, we have an interface problem with it, and that was developed on the release the day before, which I had nothing to do with, but I was surprised when it happened. Okay, but as you can see, it's a pretty simple little kit, just battery operated. Most of the processing of the radio signals is in fact done in the phone. For those familiar with software-defined radio, it's really a software-defined radio. Back in 1925, Scientific American tried to do something like this, and it failed because most people neglected to say where they were located, what day they were taking data, what time they were taking it. I had none of those concerns. The smartphone took care of all of that. So that's the group, and we're going to take any questions.
Okay, questions?
When will we see results?
Well, I'm supposedly delivering them at the UC conference in Boulder the first week of January. So I hope I have them all then.
Any questions? Okay.
Thank you.
Thank you.
Yeah, right, exactly. Good afternoon.
Go ahead.
Okay. Good afternoon, everyone. My name is Paul Dusenbery from the Space Science Institute in Boulder, Colorado, and I'm going to be talking a little bit about our public library project that we had with a number of libraries around the country around the eclipse. So I have a wonderful team with me to help me with all that. Ann Holland, Kellyanne LeConte, Greg, Jamie Harold, and Andrew Fracknoy, or Andy Fracknoy from Foothill College, Dennis Schatz, Pacific Science Center, and Doug Duncan from the University of Colorado. And Greg, do I just hit this, Lou? Oh, yeah, I'll just use that. Thank you. Okay, this is a program that was part of our Star Library Network, and we do a number of things. We've done many exhibits that are traveling around the country right now in various STEM themes, and we have lots of training programs. We are working right now with probably something on the order of 7,000 to 9,000 libraries in the country, primarily because of the eclipse. We were about 2,000 about a year ago, and because of the eclipse, it kind of jumped up to 9,000, so it's pretty amazing. Thank you, solar eclipse. This talk will be, a short talk will be about 4 things I want to cover. One is community impacts. The other is key partners. I want to show a few library results because we had about 1,200 libraries respond to our survey. And then I want to just throw out a possibility for what's next. I mentioned about, taking advantage of the eclipse and the momentum and the excitement. So I have an idea that I would like to share with you on that. So real quickly, some of the impacts. We distributed over 2 million solar viewing glasses to about 7,000 library locations around the country. They included public libraries, state library agencies, tribal libraries, even libraries in prisons, and it was just really quite amazing. We never thought that when we first started this thing that we would be reaching those numbers, but without the support from the Gordon and Betty Moore Foundation and from our other partners like NASA and the National Science Foundation, we would not have been able to do it. We estimate that about 6 million people were able to view the event safely because of this distribution program. And we also estimate that about 35,000 programs leading up to and on the day of the eclipse were offered by these libraries, reaching about 2 million people. So that's pretty cool. And this is our kind of crazy map that CNN and Washington Post and others told people about. And these pins on this map had library contact information. And when they found out that the libraries were distributing all these wonderful glasses to the public, there were people driving for miles and miles, sometimes hundreds of miles away, to the library to say, well, where are my free glasses? I heard about it, from the media. And so we had to shut down our map and the contact information because the whole thing went viral. Our servers kind of went, they also started flaming out too. So we had more problems than we ever dreamed that we were going to have to deal with. Key partnerships for this, again, NASA at My Library is a sponsor for it. StarNet, geez, I don't know why that thing's doing that. Okay. Google actually provided 740,000 glasses. NASA provided about 100,000 glasses, but the Moore Foundation did the most at 1.26 million glasses. And of course, we had to kind of find out who wants them, and that was pretty challenging too. I just wanted to shout out to NASA. They had the most amazing website, and they were able to tell people about our program there, but we also sent the libraries and people involved with this project, to their incredible website. We had our own, but yours is pretty fantastic. Yeah, you bet. We also partnered with the Solar System Ambassador Program, which is supported by, the Jet Propulsion Lab, but also managed by the American Society, the Astronomical Society of the Pacific, and Oh, that's the, sorry about that. Anywho, that's the Solar System Ambassadors had many programs that they went out to libraries and engaged the publics in those communities. We also had the Night Sky Network, which was supported by the Astronomical Society of the Pacific and JPL. So both of those organizations, volunteer organizations, were really active, and we really appreciated all their help with this. The library survey results, you could see that most libraries involved with this were rural, and that's very, very typical because there's far more rural libraries than there are big city ones. Did the library receive glasses from StarNet, or did you purchase your own? Well, the vast majority of the ones we worked with actually only used ours. Some of them did get a few additional ones, but without our program, they might not have had, hardly any glasses to hand out at all. How many programs around solar science? This is very important to us. We estimate about 5 on average programs each library did, and that gave the numbers that I quoted earlier. And did you purposefully distribute glasses to underserved and underrepresented populations? That was very important to us and from our funders, and the majority of libraries said that they did actually reach out to their underserved community. Please tell us about any science or education organizations with whom you partnered. There were a number of partnerships because of this, and I just wanted to show this one quote here. Our Eclipse programming has connected us with community collaborators and has created excitement from our patrons about future STEM programming. That we got hundreds and hundreds of photographs and quotes and all of that sort of thing, which is really, really gratifying. Lastly, I just want to mention this, that high-profile events like the solar eclipse come around, once in a blue moon, but what can we do as a community to be able to get that same energy? And I just wanted to throw this idea out to all of you. In the summer of 2019, 16,000 libraries roughly will be doing a summer reading program, and it's managed by this collaborative summer library program, and it's called Universe of Stories, and it's all about to honor the moonwalk 50 years ago. And so I just want to kind of shout out and ask all of you to join us to support libraries around the country, to maybe also have an eclipse level event during that summer, bringing in expert speakers and hands-on activities for these communities. I think, to me, that could be a very exciting opportunity. So thank you very much. And if anyone wants to have a copy of our little flyer here about our results, I have a handful of them.
Okay, we have time for questions.
Based on the success, do you think you're going to do it all over again in 2024?
Well, I won't, because I'll probably be retired by that time, but I think our team at the Space Science Institute will be doing that.
Carolyn?
When you give the classes to the libraries, do you require them to have follow-up programs? And if so, do you get any results?
I don't have any results on that, Carolyn. That's a very good question but I think many libraries now are so excited about STEM. They saw the potential and the excitement in their own community. So many of these libraries are, in fact, doing additional programming.
Other questions? Okay, Paul, thank you.
Thank you. Why don't you make an announcement while I'm...
Our next speaker is Cass Runyon. Title of her talk is Getting a Feel for Eclipses, a Tactile Discovery of an Awe-Inspiring Celestial Event.
Thank you. Good afternoon, everyone. So before I get into, Montana's in the house. Before I get into the, The why of, or the what and the how we did all the books or created the books, I wanted to explain a little bit about why it's significant to us. Since the passage of the Individuals with Disabilities Education Act in the mid-'70s, there's been a profound shift in the responsibility for educating students with disabilities. Prior to the late 70s, 80% of the students in the K-12 arena were in institutions and received very little schooling. 20 years later, 96% of those students are actually now mainstreamed into the classroom. And a subsequent study by the American Youth Policy Forum and Center on Education Policy, that's a mouthful, found that 46% of the students with disabilities spent at least 80% of their academic day in the regular classrooms, and therein lies the problem. We're just talking about the K-12 students now, but there's also the adult people who are visually impaired or blind, or like me, if I don't have my glasses, I'm blind too. And so with the national eclipse happening, we wanted to make sure that we had a resource that addressed everybody's needs. These are just some pictures here from the Florida School for the Blind. They've adopted the book and ran through some workshops with their teachers and the students. So each one of these books that we make, each page of the book actually is a labor of love. We're very careful to make sure that each graphic has its own unique texture. For example, whenever we make the sun in one of our tactile books, it's always with Spanish moss, shown here. Image, or I've actually got it, you guys can see later if you want. Sure, you can do that. And this one is the moon. It's sawdust and sand to create it so that when we use, thanks Lou, the thermoform machine, which is down on the bottom, this is old school technology, but it works really well. The pages last for a while. We have Braille on paper, it's kind of a plastic, that we put one sheet at a time, and the vacuum heated machine there will about 3 seconds to make each particular page. And then they all get sent to the printer for binding and so forth. And for this particular book, we thought printing 1,000 books would be enough. As you'll learn in a second, we've had to go back to the press 3 different times to accommodate everybody. Each of the books has a QR code on the front. And Lou can play Vanna. The QR code is used by folks that are looking at the book, that if you have a smart device, you can open up a web page that goes to NASA Ames, and particularly those with blind, visually impaired, their readers can read it at the speed that they like to hear. Several hundred words a minute usually, which to me sounds like, so I don't understand. But the content and the guide that's available on this website through the QR code is available in English and in Spanish. We've had a request to translate it to French for other countries, so we've got to work with our sponsors about that one. And then the website also has activities that can be used to accompany the book in the classroom or the informal settings. And I would like to point out the young man standing up there, he became our poster child. He works for South Carolina ABLE, which is a program to help persons with disabilities. And Justin was so excited about the book, reportedly he was jumping up and down and he wouldn't let go of it. So he kept telling people about it. The other pictures again are from the Florida School for the Blind, and the picture in the right there, Reese was so excited to get the book and to be able to teach his younger brother, who you see in the paper mask, about the eclipse as they were witnessing it together. We also put together a lot of community outreach events and shared the book at professional development opportunities. Schools for the Blind in North Dakota, Florida, California, South Carolina, commissions for the blind across the country were interested and asked for workshops. Down in the lower right there, in the upper right-hand corner, you see some rangers from South Carolina. It turns out that the totality went through 37 of the 42 state parks and all 3 national monuments in South Carolina. And the Rangers kind of had a oh crap moment when they realized they didn't know what they were talking about or what to do with all the public coming. So our colleagues from NASA came, and we hosted a wonderful workshop where they got to try out all the activities and the classes and so forth. The lower left picture there shows a colleague in North Dakota actually working a slide model to illustrate with the students who are blind so they could feel it in addition to the book. They could get the sense of the motion of the moon going over the sun. And over 4,500 books were sent out over just about a year's time frame. I'd like to share with you, anyone here from NASA, this young woman on the upper left, Brooke, wants to work for NASA so desperately. Her mother emails me about every month asking what she can do. She wants an internship. She has limited sight, but she is so interested in working for NASA.
Hey, we'll
Yay! Thank you. And I want to point out, Rick talked to us earlier this morning about some idiot looking straight at the sun, right? So I don't have that picture. But Adam's mother sent me this email. They were camping in Wyoming to watch the eclipse as a family, and he's using the book. But you also notice the far right picture, he's looking straight up at the sun. And I had this oh crap moment, what idiot would do that? She then emailed me the next day and said, oh my gosh, I forgot to tell you that he has glass eyes. It's okay for him to look at the sun. That was kind of shocking. Along with working in the PD, our professional development and workshops and just going out into the community in general, we had multiple opportunities for interviews, including the one in the lower middle. Mariah was one of our students who helped us to write the book and tested it. She was live on NPR. She's using her screen reader and the several hundred words a minute and so forth. So she got lots of great feedback. And I just want to say, stay tuned. The second page, the tactile 3 or the second page of the book is going to be updated for the eclipses in Chile and Argentina in 2019 and 2020. And 2023 and 2024 should be up there, but they got eclipsed. So we haven't forgotten about them. They'll be there. And then we thought, with a minute or so, we've got some books here. If you guys want to explore, you can take them home with you. And if we don't have enough and you're still interested in a book, just give me your business card and we can sign up. And we'll make sure that we can get them to you.
And let me add, so for our NASA colleagues at Goddard, don't take a book, I can get you a book. So for other people who are not at Goddard, let them have the books and I'll get them for you.
Okay, while they're passing those out, any questions, y'all?
Let's first thank our speaker.
If you guys are going to use your smart device, I'd recommend that you wait till you get out in the hallway because it speaks really fast. But thank you.
I have a question. Oh, yeah, I have a question. I was wondering if the young man who was blind and was looking up at the sun, I wonder if he was feeling the warmth of the sun on his face.
Actually, that was one of the activities that our blind users had recommended to us, is that you start with their face and at the shadow you create so that they felt the change in the heat just as we would with the sun, so you can simulate that.
Cool.
Thank you.
Okay.
Okay, so our last speaker is Lora Bleacher, colleague from NASA Goddard, who's going to talk about engagement with the moon. Let me do this little techno switch here. So there's your pointer.
All right. Well, thank you everyone for staying for the last talk of the session. I really appreciate it. I want to say that it's been a real joy and pleasure to listen to all of the amazing work that you guys put into the eclipse over the past several years. So bravo. It's really amazing. And you guys did a lot to really bring the eclipse to people, help them observe it, understand it, and to do it safely. So thank you. So I want to talk a little bit about the moon. So I guess you could say that I am Team Moon from Goddard Space Flight Center, where we manage the Lunar Reconnaissance Orbiter mission, which has been in orbit since 2009. So I'm going to talk a little bit about some of our efforts to really bring the moon into the conversation of the eclipse over the past year or so, as well as ending with International Observe the Moon Night. So I hope that you'll leave, if you don't know much about International Observe the Moon Night, seeing it as an opportunity to continue to engage these networks that you have worked so hard to build up. Continue to engage with them and continue to prepare them for opportunities to enjoy future eclipses. All right, so the moon really was the central player in the total solar eclipse. We could not have had it without the moon. So we worked really hard to let people know how the moon influences their viewing of an eclipse. And so we did a lot of work using data from the Lunar Reconnaissance Orbiter, LRO. You can see an image there on the bottom from our high-resolution camera of the Oriental Basin showing that rugged topography, as well as a topographic map that was made with laser altimeter data. So the cool colors represent low-lying areas, the warmer colors represent higher elevation areas. And of course, the topography of the moon along the limb affects the shape of the moon's shadow on the surface of the Earth. And then just a quick, this was showed earlier, but for those of you who didn't have a chance to see it, on the right over there, we were actually able to turn our cameras back toward the Earth on August 21st and take a picture of the shadow as it went across the U.S. All right, so as Lou also said earlier, we made a lot of stuff. And so hopefully some of these products are familiar to you. Of course, there's the map showing the path of totality. We also made a litho to talk about the moon's role in an eclipse and how that was aided by LRO observations that went into all the eclipse packets that were distributed around the country, various visualizations and animations. Of course, our own safe viewing glasses, which you can see we really highlighted the moon with those. And we worked really hard to distribute them around the country. You can see most of our efforts were concentrated along the path of totality. But some other things that we did were a lot of virtual professional development for educators and various volunteer groups. We did a lot of recruiting of lunar science, planetary science experts, subject matter experts at various conferences and letting them know what resources were available for them to go out into different communities and talk about the eclipse and the moon's role. And then you may see those baseball icons there. So one of the things that we did was we reached out to minor league baseball teams that were across the path of totality, and we ended up having events helping with events at 4 different venues. So beginning with Salem, Oregon, all the way down into Charleston, South Carolina, which you heard a little bit about this morning, and that's the event that I was at. So the Salem, Oregon team actually had the first ever eclipse delay of a game. And it turns out that their Eclipse Fest, which was a multi-day event back in August, was voted the #1 promotion in all of minor league baseball by the fans. So that has earned that team and its Eclipse memorabilia a spot in the Baseball Hall of Fame. And now they are literally beating down our doors, minor league baseball, to work with NASA. So if you're interested in engaging with minor league baseball teams across the country, many of which are in rural areas and are reaching audiences that may not typically seek out STEM events, please let me know. You can also see Noah Petro, the most famous man in baseball. That was actually an article posted by the minor league baseball organization. Anyway, please see us and we'd be happy to talk with you about it. So social media, one thing that we did this year also was really try to up our social media game. So we had an International Observe the Moon Night social media Twitter account. We changed that over to NASA Moon so we could talk about the moon more broadly. We had a lot of fun blocking the NASA Sun account on August 21st, officially blocking it on Twitter. That gained us about 25,000 new followers that we can continue to engage with lunar science content, so that was pretty cool. All right, so International Observe the Moon Night, another product that we created that was included in Eclipse packets distributed around the country as well as at multiple other events was this Save the Date card. So we wanted people to know that yes, view the eclipse, definitely, but there are other ways to experience observing of the sky, to engage with NASA, and one of those is International Observe the Moon Night. So I'll talk a little bit more about that now. So International Observe the Moon Night is an annual worldwide public engagement event to encourage people to, on one day each year, stop, look up, and observe the moon. That can be done with naked eye. You know, it doesn't have to be done with a fancy telescope. A fancy telescope is great, but it's not necessary. And so it's an opportunity to really celebrate our personal connections to the moon, our cultural connections that we all have, as well as to learn more about it, learn more about NASA's overall lunar and planetary science efforts. So here's our partners. The INOM Coordinating Committee is led by the Lunar Reconnaissance Orbiter mission, but we have partners at multiple organizations that help us out with evaluation, with engaging with our host, with recruiting hosts, developing resources. If you're interested in our evaluation efforts, which I will touch on in just a minute, please go see Sandlin Buxner. She has a poster on Friday afternoon. All right, so what do our audiences get out of International Observe the Moon Night? Well, they have this wonderful opportunity to gain access to NASA content and subject matter experts that they may not get otherwise. They learn more about what we're doing in the area of lunar and planetary science. It's important to note that they don't always just observe the moon on International Observe the Moon Night. Obviously, that is the primary focus, but they observe whatever is up in the sky, whatever planets and other objects are up, and I'll talk about that in a minute. It's also an opportunity for them to connect with their local community members and fellow space enthusiasts around the world, and then they leave the events wanting to learn more. So here you can see some numbers in terms of our annual average number of events and the people that we reach. We tend to have about half of our events taking place in the US versus half internationally. And so since 2010, when International Observe the Moon Night began, we've had over 4,400 registered events. So people go to our website, which is currently observethemoonnight.org, but that's going to be changing a little bit. I'll talk about that in a minute. And they register and tell us the type of organization that, that they have, a little bit more about their event, and then we interact with them afterwards. Issuing a survey to our host to collect data, and then we also give them a survey which we can help them customize if they would like for them to collect data from their participants and then use that for their future planning as well as feed it back to us. So what we've learned is that INOM is a really easy to implement event that's attractive to lots of different types of organizations and segments of the population. Again, people are observing more than just the moon. They are using NASA content, the resources we provide, as well as other NASA content, and they leave INOM events inspired and wanting to learn more about NASA science and exploration. Here's some comments from our host that are just echoing some of the things I just said, that this is an event that you can really take to the people. You can take to people where they are, mall parking lots, community centers, public parks. You can engage with groups that you wouldn't normally engage with when you do that, like a motorcycle riding firefighter club, as one person did. And that you really have an opportunity to learn more than just about the moon. So for 2017, we had 602 registered events, which was a record for us, in 51 countries, 46 states, DC, and Puerto Rico. You can see that since 2010, I think we've reached 99 countries, so that's pretty exciting. We're glad to see that grow. So in terms of our initial data from 2017, so far we've heard from 154 hosts. We hope to hear from more. But in terms of a breakdown of the types of organizations that those hosts represent and come from, you can see it here. It's really wide-ranging. Community centers, parks, of course, observatories and planetariums, all the way to private businesses, private residences. So we have some people that register events where they're really gathering their neighbors together, their family together, and just setting up in someone's yard. So anyone can participate in this event. All right, so additional data. We were curious to see if some of our efforts to really talk about International Observe the Moon Night with the eclipse paid off. We're still digging through that, and we're going to go back and contact some of our hosts who have responded to get more information. But we do know that over 60% of our hosts have participated in International Observe the Moon Night previously. Just over a quarter said that the solar eclipse was an influential reason for them hosting an International Observe the Moon Night event, and that they highlighted it at their event, so they continued to talk about the eclipse and reflect on it with their audience. And because LRO is the primary sponsor and lead of International Observe the Moon Night, we also always want to know how they're using our images and data so that we can continue to better support them with that as well, and about half of them are using it. So we did see a slight increase in the number of events in states that were along the path of totality. And I do want to say that also we noticed an uptick in events in Indonesia between 2015 and 2016 after their total solar eclipse. Correlation does not equal causation, but it's something that we want to look into. Social media is really important, and we found that our hosts are using social media to plan events, of course, advertise them, and they're working together. There's a huge group of about 400 users that began without our involvement. So we don't lead it or anything, and they get together and they talk and they share ideas and resources. We did a big social media campaign this year. We want to continue to do more of that, to engage with all of these followers that we got when we blocked the sun officially on Twitter. So we estimate we reached about 1.7 million people, so we want to keep engaging with them. So moving forward, October 20th, 2018 is the next International Observe the Moon Night. We want you guys to consider using this as an opportunity, again, to keep engaging your networks of people. And we would like to engage our network of International Observe the Moon Night hosts with your content and ideas and resources. So please reach out to us and let's start a conversation. If you're interested in being a partner, let us know. We'll continue to go through our evaluation data and report on that at other upcoming conferences. Really important, we're going to be working with our friends at JPL who run moon.nasa.gov, which recently relaunched with a new look and feel this past fall, if you haven't checked it out. But we're going to be working with them to create a new web home for International Observe the Moon Night. So it really will be a nice one-stop shop for NASA moon content. And with that, I'm happy to take any questions that you have.
Okay, perhaps one question. Rick?
In your list of host types, I couldn't see amateur astronomers or amateur astronomy clubs. I'm wondering, are you not taking advantage of the Night Sky Network or things like that?
Oh, no, we are. They are one of our partners. They're on the INOM coordinating committee. And we normally, when we do our overall breakdown of all of our registered events, in this case 602 for the year, we do normally break down the astronomy clubs as a segment of that. It just was not in this initial data analysis.
Okay, let's thank our speaker again. This is our last speaker of the session. I want to thank our speakers, especially for staying very close to time. I want to thank Alex Young, my co-chair, and our two conveners, Padma Yanamandra Fisher and Juan Carlos Martinez Oliveros. I stayed up all night practicing that. And I think Alex has a few words he'd like to say.
Yeah, so thank you. Those are a couple things I was going to say. I said this to the previous group, so I apologize if you're hearing me again. And I know I can't express this as well as he did, but Dan Rather, if you were able to go see him speak, talked about how we can engage the public in science in terms of telling stories. But one of the things is he talked about really these efforts are most powerful when it's lots of little efforts and big efforts all together that create the upswell. His discussion was about civil rights movement, that Martin Luther King was clearly important and pivotal, but all of the people who were doing the work were absolutely critical for that. And so I feel the same way with everything that everyone here has done for the Eclipse, and I just want to thank you all for all the work you've done over the many, many years. Many of you have been doing this since before I was born, and the upswell that we all experienced for 2017 was truly something unique in many ways, and it's shown us the path forward is going to be even better. So I just want to thank everyone here for all the work that you've done in every aspect of your outreach and science and education. Yeah, so we have time for discussion, so go ahead, Jay.
So let me first, on behalf of everybody here, thank the two of you, Lou, and both of you for the very interesting session, for Alex, because I've worked with for a long time on this, and a lot of NASA activities. It's fun to have that. I do want to point out that many people may be under the misapprehension that we have to wait for 2024 for an eclipse in the United States.
Absolutely not,
But
yeah.
for those who are not in the path of totality, and you want a partial eclipse, in June of 2020, there is an annular eclipse that comes down through Canada, near Toronto, and the whole east coast of the United States will have partial phases, and then there's an annular eclipse that goes through Texas and Oregon in 2023. So we have more eclipses than you may know, and I look forward to working with you guys, Alex.
Absolutely, and I'll also add that NASA is definitely going to continue to put more support in this, and certainly if I have anything to say with it, and I hope I do. But we're going to continue the website and make it a more general Eclipse website, which will have all of the upcoming eclipses, not just the 2024, and all the resources, and want to continue the momentum. Also, I'd like to suggest, if the speakers are okay with this, that I reach out to everyone. I have everyone's email, of course, and I gather either links to your presentations or host your presentations on the Eclipse site and put a section for all of the sessions that we did related to the eclipse. That we have a section on the NASA that either has the content there or points to where you would like me to point to. I'm quite happy to do it that way, so that there's one place people can go to and find all of this content.
We'll send out an email to each of you, and you can respond.
And then make sure that it's up as timely as possible. So go ahead, Jack. Absolutely. I will let you go ahead and respond, then I'll respond.
In February, when we just instituted technology, all the different folks who were worried about after effects related to the eclipse are getting together. And the reason for that conference is to do exactly that. That's just the RF stuff. I don't know about the visual stuff.
Yeah. So there will be more follow-ups. I mean, there are more things coming up in the immediate future. There are meetings, of course, at AAS, at AAAS. I don't know if the AAS group has a planned follow-up meeting yet. Do you guys have a planned after meeting?
We're hoping to organize a conference in Cleveland in the spring.
Okay. So I'm working myself, and I'll be reaching out to many of you. I already have, but I'll continue to reach out to you to start doing a bigger job of gathering, our best practices and foibles and faux pas and how to do things better and how things worked and how things didn't work. Because there's a huge amount of information there that's going to be important, not just for 2024, but for the eclipses before that. So. Yes.
I've also been talking with the community, communicating with astronomy with the public journals and international journal, and they also have a meeting, and we talked about I offered them the idea of doing a special eclipse edition, and they are working on that.
Okay.
So that info may come out in January.
That's great.
People can publish their results, and it'll be a special issue.
Okay. Yeah, because definitely a lot of the lessons learned and best practices is going to be really, really helpful and really, really important. And so we want to keep that momentum, and so all people also don't lose that information either in their heads or in their computers. So, any other questions or comments, or does anyone want to?
Let me just make a comment. Else? We have 17 years of big events that we've been running through the NASA Science Mission Directorate all the way back to when they were the Office of Space Science. And on at least 3 of these occasions, our big events have included solar eclipses. These are all still archived and available to the public. And so all of the work that we do for future celestial events, including, of course, the 2017 eclipse, will continue to remain archived and available.
And I just want to give a sort of a personal impression. I've been at NASA as a contractor for many years, and now in a different position and sort of see a different world. And then being in the position to do a lot of the planning for the eclipse, I do think there's a sea change at NASA in terms of the true power and broader impact that NASA and its partners and all of the agencies and groups that you all work with have provided across the country. I mean, there's a lot of people at NASA that have known for a long time the power of moon landing and Curiosity and all this, but I really do truly feel like there's a change, that it's even bigger than anyone truly imagined, and the breadth of it, because it was a unique opportunity, has really opened a lot of people's eyes up. So I think that has and is opening up more opportunities for us, for the community. So, and you had a comment, Rick?
Inspired by your earlier invocation of Dan Rather, one of the other things he talked about was how people like to listen to stories.
Yes.
And the great that NASA has, you know, thinking of Pluto flybys and Mars landings and things, is you've just got all these wonderful stories. And people enjoy hearing them and participating in them, and I think that's why you're so successful with your public engagement. So I'm glad to hear that NASA recognizes that they've got immense power and immense influence.
Absolutely, and I, you know, I was surprised. I mean, you know, NASA has inspired me. It's the reason why I do what I do from, you know, an early age. And it sort of surprised me that there were people that didn't truly get that to some degree, or didn't even understand the importance of NASA's brand. You know, the power of using the brand for good. I was sort of surprised at a lot of, you know, management that didn't get that. The other thing that
NASA has a distinction. I'm not sure this is true, but I'll hypothesize that it's true. It's probably the only or one of the very few acronyms that you don't need to spell out for people.
Yes.
They know what it is.
Yeah.
If you say no,
They don't get it. Yeah.
if you say NSF outside of a scientific community, they
Yeah.
don't know what it is. But everybody knows NASA,
Well-
even though some of them pronounce it NASA.
Right. Well, another thing that Dan Rather brought up, I had a discussion at lunch today about this in terms of science communication. One of the things that's sort of often talked about in science communication courses, and I've taken some through like Alan Alda Center and others, is they talk a lot about, you know, focusing on your message to, for people, so why should they care? You know, why is it important to them? And the thing that Dan Rather focused on is that in telling the stories that he said it was more powerful, and I think some of the experiences from the Eclipse show this, to actually focus on telling your story about why you're excited and why what you do is so fantastic and inspiring for you. So telling that story, not trying to spend your time trying to figure out what other people want to know. And that's what he focused on. And I do think I've certainly seen some of that in the Eclipse and seeing outreach and dealing with people and how excited they got to work with us and see how excited we were. And when we conveyed that, that was really powerful.
I've had people tell me that the reason they were so excited about the upcoming eclipse was because of how excited I seem to be when I'm talking.
Right, exactly. Yeah, exactly.
So as long as we're synopsizing Dan Rather's speech, Dan said, "Fear not."
Oh, he's damned to you now?
No, Dan said, "Fear not." And it occurred to me that NASA's motto is to dare mighty things. And so I might encourage everyone in this room as we go forward and start thinking about leveraging our lessons learned and what we've done for this eclipse and what we're planning for future events, celestial events, to dare mighty things and to take big risks. And we are continually faced at NASA with, in our education efforts, we have big successes and then we move on. Curiosity rover was a huge success, and then the Venus transit was even greater than that, and we thought there's nowhere we can go with this, and then here came the 2017 eclipse. So I wonder what the next bar will be. I wonder what the next high water point will be for us if we really take a few risks and dare mighty things for 2019 and beyond. So.
Yeah. So, any other thoughts or comments from anyone? All right. Well, thank you again, and I really appreciate everyone's participation. And thanks again to all the speakers and the conveners. Oh, you're very welcome. You're very welcome.